Hello, this is Dave from Dimensional Consulting. Today we are going to talk about least material boundaries as simulated by datum feature simulators as shown in Figure 7-23 in the ASME Y14.5 2018 standard. The figure looks something like this slide. The goal in this figure is to calculate the least material boundary at datum feature D. The least material boundary will be a diameter that fits inside datum feature D, inside the material. The diameter of this boundary will be different depending on which datums are referenced in the feature control frame that references datum D. We will look at the feature control frame for the position tolerance that controls the location and orientation of the 2.2 diameter hole. We will calculate what the least material boundary will be for each of the three options for how datums might be referenced. In each case, the max material boundary's diameter will be the same as a pin in the gauge that we will use to establish our datum reference frame. This will be a theoretical gauge because it will have a magical pin that fits inside the material. When the feature control frame references only datum feature D, the LMB is calculated without regard for location or orientation relative to any other datums. The LMB will be the largest boundary that will always fit inside datum feature D without regard to any other datums. That boundary will be equal to the smallest allowable size minus the amount that it could bend. Therefore, it is the smallest size of 8.2 minus the straightness tolerance of 0.1. We see the datum feature simulator in brown. It's just a ring inside datum feature D. The LMB equals 8.2 minus 0.1 equals 8.1. When the feature control frame references datum feature A primary and datum feature D secondary, the LMB calculation includes the orientation tolerance relative to datum A. The LMB will be the largest boundary that will always fit inside datum feature D when taking into account the perpendicularity tolerance relative to datum A. That boundary will be equal to the smallest allowable size minus the amount it could tilt. Therefore, it is the smallest size of 8.2 minus the perpendicularity tolerance of 0.3. Since the boundary established by the perpendicularity tolerance is smaller than the boundary established by the straightness tolerance is not used in the calculation. We see the datum feature simulator in brown. It has a surface to contact datum feature A. Perpendicular to that surface, it has a ring that fits inside datum feature D. The LMB is equal to 8.2 minus 0.3, which is 7.9. When the feature control frame references datum feature A primary, datum feature B secondary, and datum feature D tertiary, the LMB calculation includes the position tolerance that references both datum feature A and datum feature B. The LMB will be the largest boundary that will always fit inside datum feature D when taking into account its relationship relative to datum features A and B. That boundary will be equal to the smallest allowable size minus the amount that it could tilt and or move relative to datum features A and B. Therefore, it is the smallest size of 8.2 minus the position tolerance of 0.6. Since the boundary established by the position tolerance is smaller than the boundaries established by the straightness tolerance or the perpendicularity tolerance, the straightness tolerance and the perpendicularity tolerance are not used in the calculation. We see the datum feature simulator in brown. It has a surface to contact datum feature A. Perpendicular to that surface, it has a pin to go outside datum feature B, and that means inside the material. Perpendicular to A and perfectly located to B, it has a ring that fits inside datum feature D. The LMB is equal to 8.2 minus 0.6, which equals 7.6. That's today's video. If you want to see more tips like this, please subscribe and visit my website at dimensionalconsulting.com.